Today's topic is terminology in experimental designs, important terms and definitions. A number of basic aspects used in the context of the theory of experimental design are worth noting at the very beginning. The first, experiment. An experiment is a device or a means of getting an answer to the problem under consideration. Experiment can be classified into two categories: A. Absolute, and B. Comparative. Next, treatments. Various objects of comparison in a comparative experiment are termed as treatments. Example: the field of experimentation, different fertilizers or different varieties of crop or different methods of cultivation are the treatments. Next, experimental unit. The smallest division of the experimental material to which we apply the treatments and on which we make the observations on the variable under study is termed as experimental unit. Example: in the field of experiments, the plot of land is the experimental unit. Other experimental units may be a patient in a hospital, a lump of dough, or a batch of seeds. Next, blocks. In agricultural experiments, most of the times we divide the whole experimental unit into relatively homogeneous subgroups or strata. These strata, which are more uniform amongst themselves than the field as a whole, are known as blocks. Next, yield. The measurement of the variable under study on different experimental units, example plots in field experiments, are termed as yields. Next, experimental error. Let us suppose that a large homogeneous field is divided into different plots and different treatments are applied to these plots. If the yields from some of the treatments are more than those of the others, the experimenter is faced with the problem of deciding if the observed differences are really due to the treatment effects or they are due to chance factors. In field experimentation, it is a pattern. Common experience that the fertility gradient of the soil does not follow any systematic pattern, but behaves in an erratic fashion. Experience tells us that even if the same treatment is used on all the plots, the yields would still vary due to the differences in soil fertility. Such variation from plot to plot, which is due to random factors beyond human control, is spoken to be as experimental error. It may be pointed out that the term error used here is not synonymous to mistake, but is a technical term which includes all types of extraneous variations due to inherent variability, the inherent variability in the experimental material to which treatments are applied. Number 2, lack of uniformity. The lack of uniformity in the methodology of conducting the experiment, or in other words, failure to standardize the experimental technique. And number 3, lack of representatives. Lack of representatives of the sample to the population under study. The next term is replication. Replication means the execution of an experiment more than once. In other words, the repetition of experiment under investigation is known as replication. Next, precision. The reciprocal of the variance of the mean is termed as the precision, or the amount of information of a design. Thus, for an experiment replicated r times, the precision is given by 1 by variance x bar is equal to r by sigma square, where sigma square is the error variance per unit. The next is efficiency of a design. Consider the designs D1 and D2 with error variance per unit sigma 1 square and sigma 2 square. And replications R1 and R2 respectively. Then the variance of the difference between two treatment means is given by 2 sigma 1 square by R1 and 2 sigma 2 square by R2 from D1 and D2 respectively. Then the ratio E is equal to 2 sigma 1 square by R2 into R1 divided by 2 sigma 1 square is equal to R1 by sigma 1 square divided by R2 by sigma 2 square is termed as efficiency of design D1 with respect to D2. In other words, efficiency of D1 with respect to D2 may be defined as the ratio of the precisions of D1 and D2, and the ratio E is, I repeat again, 2 sigma 2 square divided by R2 into R1 by 2 sigma 1 square, which is equal to R1 by sigma 1 square divided by R2 by sigma 2 square. If E is equal to 1, then both the designs D1 and D2 are said to be equally efficient. If E is greater than 1 or E is less than 1, then D1 is said to be more efficient than D2, or D1 is said to be less efficient than D2 respectively. Next, uniformity trials. As has been pointed out earlier, the fertility of the soil does not increase or decrease uniformly in any direction, but is distributed over the entire field in an erratic manner. Uniformity trials enable us to have an idea about the fertility variation of the field. By uniformity trial, we mean a trial in which the field is divided into small units and the same treatment is applied in each of the units and their yields are recorded. From these yields, we can draw a fertility contour map, which gives us a graphic picture of the variation of the soil fertility and enables us to form a good idea about the nature of the soil fertility variation. The fertility contour map is obtained by joining the points of equal fertility through lines. The next topic is the three principles of experimental design. For the validity of statistical analysis and enhancing the precision of the experiments, three basic principles: A is replication, B randomization, and C local control are observed according to Professor Ronald A. Fisher, who pioneered the study of experimental design. Due to the Fisher, I repeat again, the three principles of experimental design are replication, randomization, and local control. This diagram here is the Fisher's diagram for the three principles of experimental design. This brings us to the end of this video. Thank you.